Okay, so we want the average rate of change of position with respect to time between t equals 0.8 and t equals 1.6 seconds, right? So we're confined to the interval from here to here, aren't we? The fact that this thing started at t equals 0 some other time ago has nothing to do with this interval, okay? Although it's the same motion, but we're just confining our attention to this one interval. So our change in position, what are our two positions? They're 12 centimeters and 53 centimeters. So that's going to be later position, 53 centimeters, minus 12 centimeters, the earlier position. Okay? And then, what about the change in clock time?
0.6.
I'm sorry?
0.8.
Yeah, we're going to have to use the 0.8 seconds and the 1.6 seconds. Now let's do the whole calculation. Let's not skip steps because this is new, right? After you've done this 100 times, feel free to skip steps. In the meantime, write out all your steps, right? So we have 1.6 seconds minus 0.8 seconds. Okay? And now the calculation is easy. We can do the arithmetic. We get 41 centimeters over 0.8 centimeters, which is, well, it's about 51 centimeters per second, 51.25 if you want to. 51.25.
51.25.
No, 51.25, never mind. Okay, but yeah, just notice I use a little wavy thing above the equal sign here to say that's approximate. Okay? Your observations are not accurate enough to justify any more than just 51. They're actually not accurate enough to justify any more than just saying 50. Don't worry about that later. But there's no point in writing out 17 significant figures here. Okay? 2 significant figures is about the best we can determine from what we were doing. There's too much uncertainty in your measurements, right? Even though you did really good measurements with the instruments that you had and the methodology, you couldn't conclude anything much more than saying it's about 50 centimeters per second. Okay? Okay. Okay, so that's an illustration of an average rate of change calculation, right? Now just one hint, because there's stuff in the homework, and I do want you to look at, more problems tonight. So you'll be prepared to move deeper tomorrow. What's that calculation look like?
It looks like the, what is that? Rise over run.
Yeah, it looks like y2 minus y1 over x2 minus x1, doesn't it? Hint, hint. Okay, that's all I'm saying. That's going to arise. But I wanted you to understand the idea of rate of change. It's explained in the problem, but that requires you to read the words and interpret them. And some people are better at that than others. I'm personally not a very good reader. I'm really good at figuring things out compared to most people, okay? So when I read something, I've got to say, what in the world is this all about? And I've got to work it out myself and redevelop it and reinvent the wheel. But there's an advantage to that. After doing that, I understand it much better than somebody who just read it, okay? But everybody has different relationship to reading, so that's just mine. So it helps, I hope, to have a video where I'm jumping up and down and yelling and screaming, okay? Because some people need to see it explained, they need to hear it, right? Okay? It's all there. It's all there in black and white in words. But I want to give you the picture as well as the words, okay?